All right. Square and cube root graphs today. What we're going to do is we are actually going to use parent graphs for square roots and cube roots to get an idea of what a sketch of another square or cube root graph is going to be. And we're going to state domain and range. So they come in basically the same form. The only difference is that one of them does not have a little index, which means it's automatically a 2. And then we have a cube root. The inside, x minus h, is in both of them, and the outside is k. Well, go back in time and you'll remember the phrase opposite of the inside, comma, outside. So this opposite of h, and then we have the k. That's our starting point. Now the a in front, it's kind of like a slope, not really. It's more along the lines of a multiplier for a square root, but the first point you find pretty much using slope, but it's only for the first point to the right and left if you are thinking about cube roots. So a parent graph is a plain, simple, it's like y equals x. And then when you're multiplying a line, so we have y equals 2x minus 3, it goes up faster, but we start at a different starting point. Same thing with parent graphs. Parent graphs of a square root basically starts at 0, 0, and then you go in increments of whatever you can take the square root. So you would have 1, 1, then you would have 4, 2, then you would have 9, 3, because you're just taking the square root of x. But it never goes negative because you cannot take the square root of a negative. So that's why it starts at 0, 0, and it only goes in one direction. We will play with that, and then you will have negative values, but the inside of a square root is never negative. Cube roots, same kind of thing, except for now you're cube rooting. So the cube root of 1 is 1, and the cube root of a negative 1 is also a negative 1. But then your next perfect cube is 8, so the cube root of 8 is 2, and the cube root of a negative 8 is a negative 2. So it has the same idea, but since you can go positive and negative, it has a different domain and range. So your domain and range for any cube root is always going to be all real numbers. But in a square root graph, if it goes up and to the right, x is going to be greater than or equal to when it goes to the right. And then if it's going up, y is going to be greater than or equal to your starting point, your h and k. Now, once we start manipulating that, we might have it go down, we might have it go left, then that changes a little bit. But your domain and range for a regular square root or any square root is going to be based on the starting point, okay? So, let's practice graphing. The domain and range we do after we graph it. So the first thing we're going to do here is we're going to say our starting point, opposite of the inside, comma, outside. So we are going to start at a negative 2, negative 4. And then what you're going to need to do is you can do one of two things. You can think about this in your head. What would give you a perfect square inside of 1? So your perfect squares, remember, are 1, 4, 9, and then you might start running out of room. Unless it starts way negative, otherwise you might be able to get to a 16. So what would make the inside 1? A negative 1. And the square root of a 1 is 1, minus 4 is a negative 3. Now you can do it by hand if you want to. However, you have this fancy thing called a TI-83 or a TI-84 calculator, where you can just type this into Y1, press second graph, and use table values. That's all you need to do. So if you type that in the calculator and you press second graph, which would give you a table, you would also get a 2, negative 2, and then you would go all the way out to 7, negative 1, and then you would just go like this. So since the graph is going to the right, your domain is x is greater than or equal to negative 2, your starting point. Remember, your starting point is at negative 2, comma, negative 4. And since this is going up, your range is y is greater than or equal to the negative 4, the y coordinate of your starting point. And that's it. So I'm not going to tell you that you have to do these by hand. Make sure you have a graphing calculator. Remember, 1/2 power is the same thing as a square root. So now we have a 2 on the outside. You'll see what that does to change. So opposite of the inside, comma, outside means we're starting at 3, 4. So your x is going to have something to do with 3, your y is going to have something to do with 4 for your domain and range. So starting point is at 3, 4. And then you just have to start working on the inside. So you're going to have a 4, but look, it jumps up 2 now. That's why I said it's kind of like a slope. So this only jumped up 1 over 1 because the slope was 1. This is going up 2 over 1. Again, it's not a slope because it does not follow that pattern forever. It's just the first dot. So if you're looking to sketch this without a graphing calculator, that tells you how to at least get to the next point. And then the next one would be 7, 8. And then you would just have a much taller graph. So this is a multiplier. It's going to stretch it up and down more because it's rising a lot faster. Okay? And that's it. So now, since it's going up and to the right makes the x greater than or equal to, and the going up makes the y greater than or equal to for your domain and range. So now this is one where it's going to get a little bit different. We're going to have a starting point of 1, 0. So we're starting at 1, 0. But now we have a multiplier of a negative 4. So your slope for just the first point is down 4 over 1. And you can already see where this is going. So then your next perfect square would be at 5, negative 8. And of course you can use your graphing calculator for that. This is what this graph is going to look like. So it's going to be going down very, very quickly because of the multiplier of a negative 4. So it's going down instead of up because of the negative. And that means your domain is still, since it's going to the right, is still greater than or equal to 1. But your range now is less than or equal to 0 because it's going down instead of going up. So that's the only difference. So the last one is, again, just another one of these examples. So why don't you pause the video and try that one on your own. Click play when you're ready to see if you got the same answer I got. Pause it. You should have a starting point of 0, 2. And your first point only goes up 1/2 over 1. And then from there, you get another point at 4, 3. Your domain is greater than or equal to 0. Your range is greater than or equal to 2. And you are done. That's it. So let's finish with cube roots. Cube roots are also just as easy. They're actually a little bit easier because I don't even have room to tell you about domain and range on this because the domain and range of a cube root is always going to be all real numbers. For all three of these, your domain is x can equal all real numbers, and your range, y, can equal all real numbers. There are no restrictions on cube roots. So how do you graph them? Very similar way. Starting point, opposite of the inside, comma, outside. So we're going to -2, -3. That's our starting point. But now you're talking about a cube root. Oh wait, you still have a graphing calculator, so you still just need to use your graphing calculator. Press second graph and look at the table. But it follows the same rules. You have a slope of 1 for the first points only, but now you're going left and right. And now you just need to go to your next perfect square, which, 6 plus 2 is 8. So the perfect square would be an 8. You also have to go backwards, and you get a -10, because you can take the cube root of a -8, and this is what a cube root graph is going to look like. It's just going to look similar to a square root, except for it's going to go in both directions. That's it. That's really the only difference. So in this next example, same thing. We're starting at 3, 0, but now we're going to go down 2 over 1 because it's being multiplied by a -2. So you'd go back that way, and then get a couple more points if you can. If it fits on the graph, just make sure you graph it using your graphing calculator in the table, and then it's just going to swoop like this, and you're good to go. So the last one, it's simple enough for you to just type in your calculator again. So you're going to start at 0, 2, but now you're going up by a half and over 1, so this one's going to be flattened. A 1/2 means you're squishing the graph vertically. Okay, it's just going to squish it down a little bit, and then you just do your little swoop, and you're done. That's it. Square roots and cube roots. This is Longo, and I'm out. See you, bye.